Hey, I heard you went. Dylan hit a home run in his baseball game yesterday for Ponderosa. Big ups. Big ups to Bill. Walk off, right? Such a stud. Such a stud. I know. All right, cool. So go back to these graphs, and if you haven't drawn these out and kind of labeled these things, do that for sure. Meaning that y equals b to the x and y, f of x, g of x, etc. Right, the different values of the base are just going to do different things. But I want to talk about, like, that's b, okay. All right, well, what does a do? What is c going to do? So I'll give you a second if you have not done that yet. Just kind of draw, and you can write this too. If you didn't write this part, the original kind of setup, a times b to the x plus c. Make sure you have that. But nothing too crazy today. We'll talk about a couple simple things. We are out of here. Let's just go for 125. So simple. You're on a nice Friday. Anybody go out for lunch? Is it nice out?
Yeah, it's
so excited. Oh, can't wait. Like all week too, right?
Yeah.
So, finally, is this real spring or is this like second fake spring? Are we gonna get that April like foot and a half storm? I don't know. Where did I move you? I don't have AC at our house. So I don't mind summer being pushed as late as possible.
I don't have AC.
Oh, we do?
Yeah. We have like portables. We have like one in the living room, one in our son's bedroom. I gotta get one in my daughter. She has bad night terrors if it's too hot. She loves to be like covered up, but then she gets really hot. And if she's hot, she gets bad night terrors.
Oh, like a heavy blanket?
It's not heavy. It's more like a wintry, like it's just something soft, like those fleece blankets. Okay. So we have a whole house fan, but it's busted. Our attic has this much insulation. I'm not.
I couldn't go in our attic. Ours not somewhere else. And now it's a whole.
I'm just waiting for like a nice like Costco sale on some portables that I can like stick the hose in the window and just cool each room separately. Whatever my electric bill doubles, but I'll pay for comfort. All right, cool. So here's what we need to do. We have to talk about these graphs and the fact that, whether I'm going up from left to right or I'm going down from left to right, on one side or the other, like as we get closer and closer either to the left edge here or to the right edge over here, right? What we talked about yesterday is that no matter how big or how small those numbers get, right, 1/2 times itself a bunch of times, let's say in this direction. So for example, like this could be like y equals 2 to the x, right? And this could be like y equals 1/2 to the x. I don't know if it is exactly, but it could be. Right? Something bigger than 1, something between 0 and 1. Well, think about what's happening in a negative exponents. So flip the fraction. So we got like 1/2, 1/4, 1/8, 1/16 going this way in terms of our y value. But like you guys said yesterday, which is great, no matter how many times I do that, multiplying 1/2 by itself, either to the left or to the right, you're never getting to 0, right? But you're going to get really, really close really quickly, and you're going to keep getting closer. And so when we talk about the x-axis, right, this right here, that spot right there, this one right here, that x-axis right there is actually a horizontal line, right? So I can write it like y equals mx plus b. It's just that m is 0, and so is b. Both of those lines, like the x-axis, is really the line y equals 0. The x-axis is the line y equals 0. And the thing that we want to just kind of formalize, just be able to like attach a name to the line that a graph approaches but never reaches, right? I keep getting closer and closer and closer to it on one side or the other. Right now I'm both. Because I got to either take off, to the right, or I'm going to come down hard from the left. The line that a graph approaches but never reaches, right? That it's like a target for this arrow. I know I'm not going to get there, but it's kind of like I want to get closer and closer and closer to it. I want to give that more of kind of like a formal name, okay? And so put this wherever you want. I'm just going to put it up here because I got the space. So I'm going to fill in the name here in a second, but it's a line that a graph approaches, gets closer to, but never reaches. Now, the word never is. Sure, in this case, yes, it's never going to reach. But if you keep going on in math, you'll see that there are some targets for our arrows. When we get closer and closer to this number, now maybe I cross it along the way. So, never say never. But I hate to be channeling Justin Bieber at all in my life, but never say never. For us, it's never going to get there. Right? It's going to get closer and closer and closer to it. Now, this word, though, is something you've never heard before. And it's weird and it's spelled strange, but it's actually, like, if you look at like where the name comes from, it makes a lot of sense. But it comes from like different words in Latin, and they smash it together to make the word. But in this case, the x-axis, the line y equals 0, a line that a graph approaches but never reaches, and along ASY, fancy new math word, that you will, if you're taking college algebra in any form next year, you'll see it again. A line that a graph approaches but never reaches. ASY M P T O T. Now that is a lot of consonants in a row right there. Okay, so when you pronounce this out loud, kind of drop the middle consonant in terms of like really enunciating that. So instead of saying asymptote, which would be kind of weird, we just say asymptote. Asymptote. Okay, a line that a graph approaches but never reaches. And with exponential functions, that line for us, okay? So in exponential, I'm going to put expo. In expo functions, it is always the line y equals c. This number right here. Now, in the case of 2 to the x and 1/2 to the x, it's 0. If we did a vertical shift, it would move the whole function up or down that far, which of course is going to move that line that a graph approaches but never reaches up and down. Asymptote. Learn how to say it, learn how to spell it. Okay, ASY MPTO. The leading A there is that like anti, like I think of a word that is like not on something, but asymptomatic. There we go. That's a good one. To not be symptomatic, right? Asymptomatic, asexual, right? To not have a gender, things like that. Yeah. It's came from Latin. There's 2 parts to that word: the asym part and the tote part. Kind of breaks it up into 2 words. It talks about like part of that is like a line, and then part of it is never equals or something. I don't really remember the etymology of the word. Here's a fancy use this in your next etymology. Use this in your next paper on the SAT. The origin of a word. Etymology. the origin of like where a name comes from. You can probably look up the etymology of your first name, or the etymology of your last name, or the etymology of any word. Like, where does the word exponential come from, or function? Etymology. That's big. Okay, so y equals c always, always, always is going to be that line. And what eventually we'll do, we will graph. We're going to graph a handful of exponential functions, and we are always going to draw in that asymptote. Okay, is that a question? Sure. Okay. The other thing that I think we will, because now we know b, okay, b is just going to help us figure out how fast or how slow are things changing. And if they're going up or going down. C, really its only job for us is to give us that target on one side or the other, kind of depending on what we're looking at. And then, so for A, what's A gonna do? Well, A controls this point right here. Because we talked about, hey, anything to the 0 power is 1, right? So plug in 0, I'm definitely going to get 1. Well, what if my function wasn't just 2x, but what if it was like 3 times 2x? Well, you tell me. 3 times 0. Think about like stopping right there when x is 0. What's anything to 0 power? Okay, and what's 3 times 1? So A is your starting point. If you want to think about a place to really begin on this graph, the y-axis is kind of a good starting point for us. Let me write this down somewhere with a darker marker. Okay. 0, comma, A is our starting point. Now, of course, I know that there's way more of the graph to the left and way more of the graph to the right. When you think about starting point, why are we starting there? You're going to see why. When we actually start doing applications of this, we're going to have a lot of stuff related to time. How much money can I make over time? Or, I put money in a bank account, how much, and I leave it there for 5 years. All right, well, the clock starts at 0, right? Look at a stopwatch. What does it start at? It starts at so you can call it the starting point. You can call it the y-intercept too, because that's really what it is, right? That's just where I'm going to be on the y-axis. But you got a little piece to add to this. Sorry, I probably should have said this from the beginning. That vertical stretch is going to mess us up. My bad. I should have said this. My brain's in like 6 places right now. A plus C is the start. Now, a lot of times C is just 0. And it's pretty common that we don't really have a vertical shift. That's my bad. A lot of times the x-axis is just going to be that nice asymptote that we approach either on the left-hand side or the right-hand side, depending on what we're doing. But if they do move us up or down, fine. Good. That's the basics. Okay. A is your starting point with a little plus C in case you need it. B just gives us a sense for whether we're going up or going down and how fast. Okay, the bigger the B value, like how much bigger it is than 1, things are going to grow way faster. Okay. And then same thing for B, but in the other direction. Like the closer to 0, right, the faster we go down. Asymptote's always going to be right here. A starting point's going to be right here. And so now that we, like yesterday, we're like, oh, I can figure out what A, B, and C are. Okay. Now let's actually use what we know to say, okay, here's my starting point. Here's how I know if it's growth or decay. And here's where my asymptote's going to be. Okay. And then we'll just end with that. So let me get rid of this. But it's all right there. And I just want to practice just a couple with you, and then we'll call it there. So I'm going to go back. I'm going to pause it here. Try this brown. Okay. So what we want to do is Like we're going to be given some function. Terrible. How about this? I can kind of see that. All right, let's make it up. After that, we'll go simple. 3 to the x. I think it's going to help us, just like we do with quadratics, figure out, okay, what's A, what's B, and what's C. And remember, this is our setup: A times B to the x. Okay, so just 3 to the x. Is that definitely exponential?
Yeah.
How do you know? The variables in the x. As soon as I see my x up there, or whatever it is, maybe it's x or t or whatever letter I decide to use, that's exponential. So the easiest one to answer now is what the base is. So I need a base. If I have an exponent, I got to have a base. What is that number? Easy. Boom. B, always going to be your easiest one. You just look right below the x. Now, A is the number in front of that. C is the number being added after. And since we can do that, now we can start answering some questions based on those. Okay? And so here are the questions that I want us to be able to answer. Okay? Where is the, now I'm going to tell you what kind of asymptote we're talking about. That line's perfectly flat, right? What's a kind of a fancier name for a flat line? Like what kind of line is it if it just stays flat? It's constant. Nice. So give me another name for a line. I love that. A line that doesn't go up or down because it's constant. Crazy one of the great stuff. Like compared to this line, or this line, or even this line. All lines are straight, good, but straight across, right? I heard it horizontal. I'm going to call it a horizontal asymptote. Okay. And the reason why I'm making that even more specific of an asymptote is because when you get to college algebra, you will see that we have horizontal asymptotes in different functions. We have vertical asymptotes, and we have slant asymptotes. Okay. Mostly with rational functions, functions that are fractions that have x's to hold. Now, for us, our horizontal asymptote is always in the same spot. Y equals 0. And when we actually go through and graph these, we're going to make sure that when we do, we're actually going to label our horizontal asymptote. We'll even like dot the line if we can. Like if it's not the x-axis, like maybe it's y equals 1 or y equals -3 or y equals 10 or wherever else we want it to be. We'll like dot a line so we give ourselves a sign. Okay. Another question, and this isn't in any particular order, is do we have exponential growth or do we have exponential growth? And why? Like horizontal asymptote, okay, cool, y equals 0. But what do you think? Is this graph going to go up from left to right or is it going to go down? And why? So we're thinking it's growth because perfect. B is bigger than 1. You can just say that. Growth because B is bigger than 1. And the only other question that I can really ask you is where's the y? Now, again, remember, I might call that our starting point. And again, once we get to applications of this here. Well, if I'm on the y-axis, x has to be 0. So I know I'm plugging in 0, and you don't have to have this memorized. You can just do that. Like you can just plug in 0 and you forget. Or we can use a super easy shortcut. It is always just going to be a plus. All right, a value, that's stretch. How far away from the x-axis should I be? And then move me up or down if there's a vertical shift. So a, 1, plus c, 0, 1. That's really what I want us to do. So I'm going to give you 1 just so you can see if you can do it. A little trick here. I'll get some A's and C's in there. If you've got the setup for sure. Okay, I'm just going to do it right here. Same exact question. Call it number 2. We'll just do this one and we'll call it. We'll call that the day. I know we still got some time there, right? I just don't want us to get too far ahead because then we'll have to like go real slow. So let's call it GBIT. And let's go 2 times 1/3 to the x plus 1. That's all. 2 times. You see how I put the dot in there? It's super obvious that x that's in the exponent is not affecting it. It's just the 1/3 that's being raised to that power. And to make that super obvious, I even put the 1/3 in parentheses. I don't have to, but I do it to really kind of cover myself so that everybody knows that when I write this thing down, the only thing being raised to the x is the 1/3, the 2 sitting out front plus 1. Okay. Let's answer the same 3 questions. Where is the horizontal axis? The line that this graph is going to get really close to, but it's never actually going to get. Use the whole equation. Y equals 1. This is an equation of a line. If you just say 1, I don't know what kind of 1 you're talking about. Right? It's always going to be the equation y equals something. And I will tell you right now, even in my upper level classes, they make that mistake of just putting the number 1 instead of 1. Because when we get to questions like, oh, where's the vertical asymptote? Well, that's not y equals anymore. Now that's or when it slants, now it's like a line, like y equals 3x minus 2. Okay. Growth for number 2. Or decay and y. What's up, folks? Tell me. Okay. Good. B is between 0 and 1. Perfect. Now, I'm writing it like with the inequalities. Just the way you said that out loud, you can write those words. You don't have to write the math symbols. If, like, knowing what direction the inequality is supposed to go might be a mistake that you can anticipate yourself making, just say, hey, decay, literally, the word, because B is between 0 and 1. Like, handwrite every single one of those words. That's cool. Obviously, the math is faster, but it gives us a lot of opportunities to make mistakes when we want to. Okay, where is the starting point? Well, so, in other words, where's the y-intercept? What's the, if I'm on the y-axis, what does that have to be? Gotta be 0. I haven't moved left or right. So I know it's going to be 0 comma something. 0 comma a plus 2 plus 1. Now, what might have made that harder is we didn't actually say A equals B equals C equals, right? And that seemed to trip us up maybe a little bit. So you see the difference between taking literally 6 seconds and writing this down, right? It made that third question maybe just a little bit harder than it needed to be. So if you think it's helpful, A equals 2, B equals 1/3, C equals 1, and all the answers are sitting there. Sweet, I'm good. Right there is good. We will pick some stuff up on Monday. Nothing you have to do for me this weekend unless you need to get caught up on anything. Here's your opportunity to do so. Grades for quiz 4.1b will hopefully go in this weekend as well. I do have calc tests to grade earlier this week though, so those are getting priority. And then I'll get ours in after. But we got like 5 minutes to hang out for that. I know, right? You guys are good to go home. Thank you for being here. I'm gonna stop recording.
Thank you.
Bye, Danica. Thank you all.